Since concepts on open and closed sets may be used later on as we look forward on the topics on measure functions or measures in general, let us try to reintroduce them. Let's start with open sets, and we'll have a separate video for closed sets. An open set here is clearly defined in this manner. A set U, subset of the set of real numbers, is open, okay, if for every point, let's say x element of your U, okay, there exists an epsilon greater than 0, no matter how small, such that the open interval, okay, take out open interval, x minus said epsilon, and then x plus said epsilon is entirely, take out the term, entirely contained in U. This is how we identify whether a certain set is open or not. Let's try to consider this interval here, U sub 1. What if I have the interval 2 and 5? Okay? This interval may be identified whether it's as open or not by looking into the possibility of, let's say, any value of epsilon. Let's say x is a 3 and epsilon at, let's say, 1/2. In the Cartesian plane, 1, 2, 3, 4, 5. Pardon for not having accurate grids. So 1, 2, 3, 4, and 5. Our x is at 3, and our interval is at 2 to 5. Okay? If we have epsilon, which is equal to 1/2, so this is our x minus epsilon, you will have this value here, and plus epsilon plus 1/2 minus 1/2 here. This entire value here, the open interval, which is 2.5 to our, what they call this, open interval 2.5 to 3.5, is entirely contained in our U, this red portion here. This signifies that your set U sub 1, which is in interval 2 and 5, is actually an open set. And take note, we, as long as we were able to identify epsilon, and then we have that, so it's also okay. What if our epsilon sub 2 is equal to 1? Is it still included here? Take note of this. If we have 3 minus 1, so you will have here, which is open interval 2 and open interval 4, you will have here 2 to 4. This is still included in U. Therefore, this is still a verification that this is true. Okay? So that is for every x rather. So if we're going to look as well another x value here, and no matter there exists an epsilon such that it will contain everything, that would mean our U, our set is an open set. Now what if I have this second U sub 2, let's just say in this, I'm going to write another interval later. So we have 3 and 4. In our Cartesian plane, you will have here 3 and 4. These are our elements. Is this open or not open? I'm not yet sure if it's closed, okay? So is this open or not open? Take note that if we are going to say x, since x should be an element of U, right? X should be an element of U. So what if x is a 3 and our epsilon is 1/2? So for our interval now, so we have here 1/2, 1/2, right? So you will have open interval 2.5 to 3.5. Is this entirely contained here? The answer is of course no. Yes, it includes a 3, but these fractions here are not part of this because this is a finite set together with all the entries here. So if it's not entirely contained, even if you're going to use 4, definitely this is not open. As to the identification whether it's closed, we will be having this illustration on a separate video after the definition of a closed set. But here, this first set or interval is open, but the second is not open. Okay? Based on this definition. Thank you very much for watching.